So in this video, I'm going to do the same problem I left off with in the last video. I'm going to do number 4, but I'm going to do it that second way that I mentioned. I ran out of time earlier because my daughter woke up earlier from her nap, but I did want to make sure to cover it and talk about how to do it the other way. So it's the same problem. When you have 30 orange trees are planted on an acre, each will produce 500 oranges per year. For every additional orange tree planted, each tree will produce 10 fewer oranges. How many trees should be planted to maximize the yield? So if we do it the other way, instead of letting X be the number of trees, we let X be the additional trees planted, and our revenue is still the yield for each tree times the number of trees. But how we would do it is we would just write an expression from each based on the problem. So for the yield for each tree, it says we start with producing 500 oranges, and then for every additional orange tree planted, each tree will produce 10 fewer oranges. So what I would do is I would take 500 and then I would multiply 10 by X, because for every additional tree planted, I'm going to multiply it by 10 to get the total number of fewer oranges that we would have, and then subtract it from what we started with, which is 500. Then for the number of trees, I would start with the 30 trees and I would be planting however many additional trees we decide to plant, which is X. And this would be my revenue equation. So we want to maximize it, which means we need to take the derivative and we set it equal to 0. So I'm going to again multiply this out. You could do product rule. It's whichever one you're more comfortable with. So I'm going to do 500 times 30, which is 15,000. And then 500 times X, which is 500X. Then my inner negative 10X plus 30, or sorry, times 30, which is negative 300X. And then negative 10X times X, which is negative 10X squared. So I combine my like terms. I'm going to take the derivative. So 15,000, 200X is 200, minus 10X squared is minus 20X. I'm going to set this equal to 0 and then solve for X. So I would add 20X to both sides, and then I would divide by 20, and I get X equals 10. Now again, this is the additional trees. Now just to verify it's a max, I take the second derivative, 200 is 0, negative 20X is negative 20, and so it's concave down everywhere, which means at the critical point of X equals 10, we have a max. So the only thing is we need to make sure we answer the question. And because it says how many trees should be planted, that's the total trees, not just the number of additional. So remember, we started with 30 trees, then I'd have to add the 10. So I should plant a total of 40 trees. So just make sure you're answering the question. And if we look back just a minute, the other way we did it with finding the equation for the number of oranges each tree yields and then just multiplying it by X being the number of trees, we also got 40. So it doesn't matter which way you do it, but if you do it this way, make sure that you're actually answering the final question and adding it to the initial amount. Okay, so that's how you do this problem the second way, and then I'll do one more video of one more example.